Today we're going to be looking at VERICUT's force optimization. Force is physics-based optimization that recalculates feed rates and subdivides motions in order to maintain a constant ideal chip thickness for machining as much as possible. And simultaneously, when needed, it will reduce feed rates in order to avoid excessive cutting forces and spindle loads. Let's take a look at the part we'll be machining today. This is a titanium piece of material. We can see the part inside, so we can see what we'll be creating. It has very typical aerospace geometry. It's a titanium part, so not the easiest to machine. To focus on the machining, we'll use VERICUT's workpiece view. VERICUT Force needs three things in order to be successful for you. First, it needs you to verify that the part you're machining has a good, clean NC program with no mistakes or errors. We've already done that in this VERICUT session. Second, it needs intelligence about the machining tools and what they're capable of machining. So if we look at VERICUT's tool library, we'll notice it has stock material records, and these records are defined for use in titanium metal. You can have any number of stock material records under any cutter, and each one is unique to that cutter. So you can have roughing versus finishing, and of course different shape end mills as well. I'll show you a little bit more about these later. The third thing VERICUT needs is it needs to know what type of material it is you're actually cutting. You do this in VERICUT's Optimize control window. When we go to optimize the NC program, since we're using force technology, we'll go to the force material catalog, and we'll want to search for the titanium material that we're looking to machine. As we key in the filter, VERICUT filters down the list to show us various grades of titanium. You can also use alias names for material. So if titanium isn't a name that's familiar for you, and maybe you're familiar with something like TC4, you can filter in by that name as well, or by these ISO code groups, whichever is easiest. When you see the material that you want, you can right-click on it and send it to the Optimize control window, and boom, it ends up over here. You also have that same option at the bottom of the window. We're now ready to optimize. Here's the NC program that VERICUT will be simulating. As you can see by the notes inside, this program contains adaptive milling motion, which is cam optimized NC motion. We'll be seeing what force can do with that. As we start the simulation, optimizing is taking place, and we'll be able to see what VERICUT does with this motion as far as feed rates and machine time. Up in the upper left corner, I have the head-up display configured to show us the program feed rate, which you can see is rather motionless, and the optimized feed rate, which you can see there's a tremendous amount of activity going on over here. These are the different feed rates that Force is calculating for us and outputting to a new optimized NC program. The machine time, and then the optimized machine time, where you can see the difference. Down in the lower right corner, I'm using the tool use graphs to show the difference between the original NC program and the optimized NC program.